Alright, so hello and welcome to the talk on building a backend system using Kotlin. It's not going to be an advanced Kotlin talk. It's more like the concepts involved and what we're going to, you'll see what we'll be doing. So there are no hard prerequisites for you knowing Kotlin very well or actually almost at all. Alright, so a little bit about myself. My name is Cosmin Ştefan. I'm the co-founder and technical engineer and technical lead at GDG Pastures. This is a mobile company which has an office in Bucharest and in Denmark. And I've been doing software development for quite a while now, especially on Android. But then I've been doing all kinds of projects as well. So backend as well, front end, JavaScript, and different types of what kind of depends on what the projects require. So as I was saying, the goal for today is to walk you through how you can very easily build a backend for yourself. It can be for whatever, and we've been doing this. So basically, at my company, we're doing mobile apps, but sometimes you obviously need some backend, some APIs and stuff like that. So I'm going to walk you through the solution that we picked, just because. It seems to work really nice for us, and it's something that anyone can easily do very fast. So probably since you're here, you've all heard of Kotlin, and I don't know if you've been to Magda's talk earlier today, which was an introduction. There are plenty of reasons why Kotlin is a very powerful language, and one that's definitely worth trying in different, in all kinds of projects. First of all, it's a very powerful language, and it's general purpose. It wasn't built with something in mind. A lot of people think it was built for Android or something like that, but it's not. It's basically a JVM compatible language, which can run anywhere JVM does. It's very easy to learn, so it kind of comes with the same concepts as all the other classical languages, but it's also really easy to use in certain situations. And it also comes with a lot of tooling and really nice tools. If you don't know, it was built by JetBrains. JetBrains is the company that builds the IntelliJ IDEA, WebStorm, or PyCharm, and all the very cool tooling. Even the tool that Android Studio is based on. And the fact that it's a JVM compatible language means you can run it anywhere Java works. So it can be run on desktops, it can be run on servers, it can be run in a bunch of places. So that's why they actually came up with a very nice plan of being able to run Kotlin in a lot of places. So obviously people have heard about Kotlin on Android. That's the simple case. Then we can have Kotlin-based server side. This is what we'll be talking about today. Besides this, some of you might not know, but you can actually build something called Kotlin native, which means you write the code in Kotlin, and then it can build as native code, and it can run on a Linux machine, on an iOS device, and in a lot of other places. Also, there's a compiler that takes Kotlin. Something's wrong with the mic sometimes, it drops down, right? Yeah. Let me know if there's any problem with the sound, let me know, I can take it off or use the other microphone or anything. The other thing is that you can use Kotlin for browser, for doing JavaScript applications, because you can write the code in Kotlin and they compile it automatically to JavaScript. And obviously it works with all the NPM packages and everything that JavaScript comes with. So I hope I've convinced you to give Kotlin a try. So let's see, let's take our use case and try to build a backend in Kotlin. And let's see if this remote works. It doesn't seem to be. Oh, it does. Cool. So we've decided to build our backend in Kotlin. Let's see how what we'll do next from there. Well, we have quite a few options. First of all, we need for a backend device, for a backend server, we can use Spring. Have you guys heard of Spring, or you know what it is? Well, Spring is a very old framework. It probably has almost like 20 years now. It has a lot of plugins, features, and all that. And since it's Java framework, it obviously you can work with that in Kotlin as well, because Kotlin compiles to Java bytecode in the background. So also the guys from Spring, they did a little bit of effort to make Spring work with Kotlin. Then there are a couple of other very powerful Java-based frameworks such as Vertex and Spark. They're also Java-based, and they work with Kotlin, of course. And then there are two more examples here, which are frameworks for the web that have been built specifically for Kotlin, in Kotlin. So they're kind of, I would call them Kotlin native, and they work just like that. So as you can see, we actually have quite a few options on how to get this done. And from my perspective, I've tried, my proposal to work with is called Ktor. And let's first walk through why I think this is a very good solution. What's Ktor? Basically, it's a framework for building backend, but you can also build client-side servers with it. It's asynchronous, and basically it's built in Kotlin, and you can work with it really easily in Kotlin. It has very strong backers. As I said, first of all, it's built in pure Kotlin, and then it's again built by JetBrains. So it's their official framework, so they've done a lot of effort into making it work really nice with all the very cool features in Kotlin. So the integration is really nice. Then it's really fast, and it's not, I call it lightweight. And also it's unopinionated. It has plugins, you can add stuff on it, but for example, if you're using Spring, you come up with, you're kind of forced to use their dependency injection or some of their tools. Here, they kind of took a step back and leave the developers make a choice for their tools. Also, it's really fast. For example, like a brand new project starts in less than 1 second. A backend project which has a database connection and everything starts in like 1.5 seconds or something like that, compared to like 20 seconds plus in Spring. All right. What's next? It has asynchronous I/O. That means that, for example, if you're from the server side, if you're reading some files, if you're querying a database, if you're calling another server, those requests don't block the thread, which means more requests can be done in parallel, and that's really cool for performance. Under the hood, it's backed by something called Kotlin coroutines, which is a very fancy way of doing threading in Kotlin, and it's using something called Java Neo, which is the latest version, like one of the latest ways of doing I/O in Java. The last point I have about it is that it has a very powerful way of deploying stuff. For example, you can deploy it in servlet containers. You can send it in, like you can run it in Tomcat or Jetty. You can run it as a standalone. For example, you put it in a Docker and run it on a certain virtual machine. And also they have native plugins for running this in App Engine or in Heroku or other of the cloud providers. So that's really easy to set up. I mentioned it's unopinionated, so it comes with, it gives you this choice. On the other hand, it's really powerful, and it adds support for a lot of features that they have implemented that are really easy to set up. We're gonna walk through some of them in the next slides, but this is a quick summary. Basically, you can set up authentication and session really fast, and they deal with cookies and everything that's involved. It does course and HTML templating, so that can also be done, can help you a lot if you're building a backend for a website or a platform. It deals with serialization, it deals with compression, and then it has even more features. So for example, it can deliver static content, it knows HSTS and WebSockets, so you can also use it for those kind of projects. And also it has some nice tools for developers. For example, it has auto reload, which you'll see it helps you write code and test it really fast. Also, it has support for automatically gathered metrics, so you don't have to write your own metrics endpoint or do something like that. All right. Besides this, it actually has like way more features. You're very much free to check out a website and see some of the extra features they have really easy to install. Okay, so the plan for today is to build a project, a backend, and we'll go through all the steps of setting this up. First thing is setting up a project. Should we, like, is the sound annoying or it's okay? Okay, let me know if there's any issue. So we'll try to build, let's say, a backend for a to-do app let's say we have an app where you can add some to-dos, and then you can get them, and then you can modify them and delete them and stuff like that. Very simple functionality, but we're gonna go through all the steps. So this means this project could scale up to a way bigger one. So first part, it's setting up the project. JetBrains has put some effort into building some nice tools for this. There's something called start.cater.io, which is similar. For example, Spring has a Start Spring website as well, and they also have an IntelliJ plugin. What this does is that allows you to kind of pick up some options. Let's say you want to use some HTML templating, so you can use, let's say, Mustache or Timeleaf or something like that. You want to add logging, you want to add OAuth or basic authentication or session handling or stuff like that. Basically, you just pick your dependencies. What the website does after that is that it sets up a base project. This base project, it's already set up with dependencies, it's already configured, so you can basically just import the project and hit run, and you'll have a fully functional backend with all the features that you've already pre-set up in the previous slide. The app, it's gonna look, so this is what you get right after you start up, you import the generated project. It's a simple Kotlin app, and basically it has three important parts. First of all, since it's Java, it has to have a main entry point, and that's where we go basically specify, hey, we want to have an engine, we want to run our main application. Then we have a big block called under the application.module. Basically here is where we specify and configure our own application. In here, there are two sections. First, you can have this place at the beginning where you usually install what they call features. Features are the things I mentioned earlier. So these are basically things that Cater automatically implements, and just by a line or a few lines of configuration, you have them set up and you don't need to worry about that anymore. Then you can have a block with routing. So basically this is where the magic happens, and this is where you can configure the routes, the paths, the URLs, and how you handle them. We'll go into, no worries, we'll get into the details for each of the section in a few slides. The most important bit is to remember this structure where you kind of have the initialization, you can add plugins, and then you can define your routing. All right, let's talk about some of the very easy features, and I call them easy win because in a couple of lines of code you can have a lot of nice things set up. So no worries, no hard work for you. First thing, as any developer, you know that logging is one of the most important bits. So by default, they actually set up SLF4J, which is the most popular framework for logging in Java. That's already pre-set up. And they also have a very nice feature called autocall result logging. Basically, they log in your, every time a request comes to your server, that goes to the logs, so you can easily walk through the app and see what happened and when. How you use it, basically the logger is already set up, so all you have to do is just get log and then log whatever you want using the LSF4J. And to set up the other feature where you get automatic request logging, you just have to write these 3 lines of code. Actually, just the first one is enough. Basically, you install the column logging feature, and then you can configure, hey, I want my logging level to be info, and then I want to filter only on some subsets of the application or something like that. All right, the next bit is that we're developers, so we want to see really fast what's going on and if what we've built runs as it should. So they have an auto reload that's really easy to set up. Basically somewhere in the configuration files you just have this one line of code where you say, hey, I want you to watch any changes that happen in these Java modules, Gradle modules. If any change goes in there, the code automatically reloads as soon as you build it. So basically you write your code, you hit build, and instantly the app is kind of, let's say, deployed on the local host, and then you can just refresh in the browser or make your queries or do whatever your app is doing. This is really nice, one-line auto reload. It's a really cool feature, especially for backend APIs, backend frameworks. Then compression. Compression is really important, especially for example, like mobile devices or even for web if you're doing a lot of requests, because it helps the data, basically it helps the speed of the website or the app by compressing the content. So basically everything that the server responds gets compressed, so it takes less time on the, I don't know what happened. It takes less time to go through the network. It automatically can do this, so it already supports by default like three versions, and there's all you need to do is basically again install a feature. You can configure it there. You can say, hey, I want to install compression. I want that to automatically work with gzip, and for higher like bigger packages, you can use deflate. Then there's the topic of content negotiation. This is sometimes like people call it serialization, deserialization. They automatically do this, and they do this based on the HTTP headers. There are two content headers. There are two headers that are important: the content type and accept headers. What this deals with is, for example, in your code, you can return classes or objects of different types, and then they automatically serialize it, for example, to JSON if the client requested JSON, or to XML if the client requested XML. And the engine, the cater, does this under the hood, so there's nothing you need to do as a developer based on this. You just return your own objects. So let's see how this works. Of course, you just have to register a very simple feature. It's called content negotiation. In there, you can just configure it. For example, here I'm saying that I want for the JSON type, for the application JSON, I want the negotiation, the serialization and deserialization to happen via Jackson. Jackson is a very popular Java-based serialization framework. Then, for example, in one of my routes, I can just respond. In here, I'm responding directly with an object. And then the platform will automatically deal with converting this to JSON, XML, or whatever format the client requests. The same thing goes when the data comes in. So for example, if you're implementing a post request, the client will usually make a post request with some stuff. So for example, it posts a new user profile or like new data to the server. You can automatically deserialize this, and they do everything under the hood. The other way around. Again, for the JavaScript world, there's something called COS, which is a protocol for helping out with the security around JavaScript requests. They have automatic handling for this, so from our perspective as developers for backend, there's nothing we need to do except for installing this feature and configuring the right settings. So, for example, here I'm saying that besides the default methods, I want to accept course, or like set up course correctly for patch and options. I want to accept a custom header, and I want this to work only on example.org or www.example.com. You can configure this based on how your app works and what the requirements are. The last feature that I want to go through is templating. Basically, it has a very nice feature to automatically build HTML responses, and it supports all of these templating engines. If you've ever done this before, I'm sure you're going to recognize the names here. All you need to do is, as before, you install a feature. Let's say I want to use mustache templating. I configure it, and for example, there I'm saying what the folder in which my templates are. And then all you need to do is basically say, hey, I want to respond with the to-dos template, and I want to pass as arguments a real, let's say, to-do or something like that. That goes as an argument inside the template, and then the template can take it out to create the answer. Kotlin also comes with Kotlin DSL, nice way of writing HTML. If you're into writing the HTML like as type safe into Kotlin, you can also do it in formats such as this one, where you kind of have tags and everything for every of the HTML tags. All right. We've gone through some of the features. Now it's time to, so basically the features that we had are features that you would most likely set most of them up when you're starting the project. Then let's see how we actually build our logic and how things work in a real implementation. The component that does this, or the thing that does this, is called it's called routing. And what it does, oh, sorry, the other way around. And what it does is that it provides easy support for handling requests and doing this in a very simplistic way for us as developers. It has two main goals, or roles. Basically, it allows you to define what are the valid paths for your requests, basically the URLs to which your server responds. And then for each of them, it gives you the option to define a function or whatever, like write the code which handles that particular request. As I told you at the beginning of the presentation, that happens in a routing block. So you need to write a routing block, and in there you kind of define your own requests. For example, let's say I want on the root of my new server, I want to respond with hello world text. All you need to do is something like this. Basically, that function, like whatever is under get, that function will get called once someone sends a get request to the slash path of your server side. Then you can just do whatever logic you want and then respond with your content. You can also do something very nice called nesting. Basically, if you use this route thingy, you can nest certain requests. So what I did here was I'm basically saying that everything that's in the block, that's within this route, actually will be relative to this slash API slash to-dos endpoint. So for example, if I have this, if I have this get request here, it's actually, the final path will be slash API. So basically it's going to be a get on the slash API slash to-dos. And what I'm doing here, it's not really relevant for the purpose of the presentation, but we're, let's say, loading some data from the database, and then we're responding with it to the client. You can also do, like, basically nest these things. Basically, it's building a tree of routes. So for example, here I have a post items, and basically that means the final path is going to be slash APIs slash to-dos slash items, because it kind of adds up on the paths as long as you nest them down. Since you have, like I've shown you this option of writing the routing, you probably wonder what happens if you have a big server side and you have a lot of code. You're going to end up with like a few thousand lines of code in your main application. So that's why they kind of added a nice support for cleaning the code up and separating it into modules. And the thing is based on these routes that I've defined previously. That way you can basically define and move your APIs into a particular package or into a particular class, and then have your logic there, and then separate the concerns and have multiple teams work without any issues. It works in a very, I'll walk you through the main idea of how this works. So let's say you want to build these to-dos APIs. Like I mentioned, we're building a to-dos backend, so let's see how it works. Basically, I would make, it's something called an extension function in Kotlin. It's not really relevant for the purpose of this, but basically I'm building a block where I'm defining my to-dos APIs. In there, let's say I could also get some dependencies. So here I would depend on a data repository or a web server or another service or a database or whatever else you would need in your business logic. Then I would define my own route. I would call it to-dos in this particular case. And in there, as before, I'm defining my endpoints. So for example, I'm going to define a get request. Then again, I'm going to nest some stuff up. So under items, I'm going to define a post request for adding a new to-do. And then let's say I want to delete an item. This is where a new concept comes in, which is dynamic parameters. So our path, I'm not sure you guys can see very well, but basically I'm using some curly braces around the ID name. That means that whatever when the clients make a delete request, they can actually put a variable thing in there. And then using this call.parameters, actually it's a map. This map you can actually load whatever the dynamic parameters are, and then we can use them. So for example, in this case, I can just delete the item with an ID based on just by making it a delete request to the right endpoint, following the REST principles. All right. Let's see what's next. We've defined our to-dos API in a separated block. Then we obviously need to set it up in the main application. So going up to our main app module, again in the root routing block, here is where you would, via these, like basically on the previous slide, I named my function up there. It's called, let's see, to-dos APIs. That's the name I've given to my API module. I would expect the screensaver to not go in while it's full screen, but hey. All right, so I defined my to-dos API here, and then in my main app, I could, for example, let's say I would have another web app. I would have another web app routing. Then I would have another web app module. I could, for example, install that in the root. Then what I could do and make things very nice is basically I would group all my APIs under /API/v1, and then in there I can actually here I can run my to-dos API. That registers my route handling in here, and basically if you remember, like the root for the to-dos API was /route /to-dos. That means that all my endpoints in my to-dos API will actually have a final URL of /API/v1/to-dos. And that kind of helps me group things up. Still in the main app, we have a very general view of how things work, and like you can find your way through the app, but you can also break the code into different parts. Okay, so so far we've set up a project, we've installed some basic features, and we've done the code for we've gone through the code of how you do routes and how you handle various requests. As I mentioned before, Cater have gone for an unopinionated way of doing things. They don't force you into anything. They said, hey, we're a web framework, so we'll provide some automatic features for web, but that's not going to be for some other, let's say, more detailed things. Dependency injection is something that kind of pops up into mind really fast. It's something that's really common in big projects. You kind of cannot do it without. And in this particular case, they haven't done anything for dependency injection because their purpose is being a web framework, not a web framework and dependency injection and something else and something else. And then you end up being Spring. So they let us as developers choose our tools. I'm going to talk about dependency injection, and I'm going to talk about a tool called Coin. It's a very simple tool that works really nice and can help you do dependency injection in any Kotlin project. This Coin works both in it can also work in Android, it can also work in the web, it can work in anywhere we have pure Kotlin code. Basically, they're a lightweight dependency injection, and they've been built for Kotlin, and it only works in Kotlin. So it has a very good performance. It's using some of the very fancy features of the Kotlin language to make this work without any proxies, without generating any code, and more importantly, without any runtime reflection. It's also fully typed, so it works really nice without having any performance hits for your application. It has two main principles. There's one place in the app where you define your modules. Each module basically says or defines how you get your dependencies. You have one place where you define, hey, if someone asks for I don't know, data repository, like to-dos repository, this is how you get one. If someone else asks for something else, then that's where you kind of instantiate them once or define how they get created. Then the second bit is that you can do lazy inject whenever you need them. Okay, let's see how this works. So let's say we have two classes, two services. One is called authentication service, and this takes no other dependencies, and the other one would be a data repository. This data repository would get, let's say, it would require the first, like the authentication service as a requirement, as a dependency. Cool. Then what we need to do is build our module. In this module, we would have some single, let's say, we define our dependencies. With that single keyword, what I'm saying is that, hey, every time you give me, like I'm asking for an authentication service or for a data repository, give me the same instance. Basically, give me a single instance of that thing. Here, since this one doesn't have any dependency, I'm just creating it. Here, I'm creating it, and this is a constructor. It's missing the new keyword, but that's how it goes in Kotlin. So basically here I'm using this get, which via generic types, kind of figures out, hey, this guy wants me to give you an authentication service. So basically, here you actually get this instance, and whatever. If you have other dependencies, they automatically get filled in and they get populated over there. Of course, we have this module, we need to install it in our main application. So as before, we need to install a feature. Coin has good support for Cater, so they actually have built all the logic around that. So all you need to do is do this install coin. Here I'm also like installing the logger, so it automatically logs stuff. But then you need to do this modules method, where you define your main module or whatever other modules you have in your app. Then, for example, whenever you need it, you write something like this. You write a by inject, that's using property fields in Kotlin, but magically then that's going to be a property which will have your data repository. Doesn't really matter where it comes from like at this point we don't really care where it comes from, but we have it and it's available and you can just use it. You can, like, for example, use it in your requests or whatever you want to do with it.
How do you control the life cycle of that instance?
So one of the most, so for example, that single kind of says, hey, I want this to be a singleton, yes. But there are more ways of doing this. So besides single, there are other keywords. So for example, you could say, give something to me only in this particular scope, and then if you destroy that scope, you can lose that. They have a session scope, for example, so you can have a session there. So they're going to give you the same instance during the same call, basically during the same session. But they have a couple of keywords there that you can use. Single just says singleton. There's also one that kind of creates a new instance every time. But the upside is, for example, you can, if you're doing tests or something like that, at tests, like in the tests, you can swap the real dependencies with some, like say, a mock module, which provides mock data repository or a mock authentication service. So you can test the exact same code, but just with like different dependencies in there. That's the biggest benefit. Right. Moving forward, the next thing that we kind of need in our backend application is a place to store data. And of course, SQL is kind of the most popular. So we'll go through how you would make your service work with an SQL framework. I've gone for something called Exposed. Exposed, as before, it's also a very lightweight library, and as before, it's also built by JetBrains. So that means they have a very good integration with Kotlin, and it's using some of the very fancy features in Kotlin. You'll see that in just a few slides. It has two ways of functioning. You can either use it just as a DSL, so basically you can write your SQL queries, but in a type-safe way via Kotlin. I will show you, like, we'll go to that in 2 slides. Or they actually have an option where they can create data access objects, and basically they just write how your, let's say, to-do class looks like and how your user class looks like, and they automatically generate all the DAOs for that and all the methods for selecting all and all that stuff, and also manage the lifecycle of the objects. Besides that, it has a very nice type-safe functionality. Basically, it's a type-safe tool. So, for example, if you have one of the columns in your database, it's a string, you will not be able to write an int to it, basically guarding you against mistakes such as this one. And of course, it kind of comes up with all the full querying support you have in SQL. Again, then the question is which dialects it supports. It works with the biggest and actually most of the more popular SQL frameworks. The first 3 are the most popular, basically Postgres and MySQL and H2. It also works with some other tools such as MariaDB or SQLite or even Microsoft SQL Server. So it kind of deals with all the abstractions and like little dialect-specific things in the background. Let's see how you would use something like this. First, we need to define a table. We define these tables via the DSL. So here I would say that I want my users table to have an ID, which is auto-incremented, and this functions as the primary key. This is all compile time checked. It's really nice. Then you can also have a name, which you're saying it's a varchar, and so on. Then, when defining our second table, you can actually do more things, such as a reference. So with these references, I'm saying, hey, this is going to be a user ID, so it's going to reference users.id, which is going to be this one, with the cascade referencing type. The upside for this is that it's giving us a lot of checks. Basically, it's creating foreign keys. It does all the magic under the hood. All right. Next bit, how you use it. In the main app, we're actually here in my particular, I have a repository, so I'm abstracting my database logic in one place. I just connect to the database. In here, I've chosen an H2 in-memory database, but you could just use a MySQL server or something else. And then basically, they have a lot of tooling for creating tables, for migration, for updating tables, and all that stuff. Then, in practice, let's say I would build this load to-dos function. You can actually just make it a transaction, so everything that runs inside it works like follows the transaction semantics, and then you write your SQL queries such as this. Basically, I'm gonna select something on the to-dos, and then in here I'm gonna check this user ID to be whatever parameter I got, and then this is gonna give me a result object, so I can just extract it and map it to transform it to something else. I'm not sure how visible that is. I should change this on the slides, but basically it's going to generate a very simple SQL. It's there right on top. Basically, select star from to-dos, where to-dos user ID is the user ID. You can also do slicing. Slicing means just select certain columns. So in here, I'm just loading the description column, and I'm selecting all of them, and whatever I'm consuming them afterwards. All right. So, final step. We've built our app. We've set up, like we're using dependency injection. We have some very fancy routes. We have been interacting with the database. The next step is like how we get this to the real world. I'm gonna, like, as I mentioned before, you can like ship it in a Docker, you can ship it in a serverless container or something else, but I'm going to show how you would ship this to the cloud. They have a very nice integration with, for example, Google Cloud. All you need to do as prerequisites, you need to set up the project on Google Cloud, set up whatever needs to be done there, like billing or whatever, and then you have to install this gcloud CLI. Then, in your build.gradle file, this is like the Maven equivalent for like the newer dependency management solution and building. Basically, you need to do two things. One is basically I'm loading my plugin and I'm applying my App Engine plugin, and I'm making sure it runs at the end of the script. Then I also need to add some App Engine dependencies inside my app, and that's kind of it. This is all the configuration I need to do to my code. Then, for example, I can run the server locally. I can do it via this App Engine run thing, and it's gonna emulate the full App Engine environment and as the app would run on App Engine, but locally on localhost. Or I could choose to ship it to the cloud. So for that, I would first need to create an app, which goes via this very simple command, and then I would do the App Engine deploy command. Once this gets done, ta-da! We have our app running in the cloud. With all these, like the two lines I've showed, like actually the App Engine deployed one, they just ship all the app to the cloud. You have it available there, and it runs and all that. What to keep in mind? My suggestion is to always give like the latest technologies a try, see if they work for you. They might work, they might not work. For us, this Skater has been working really nice. We've been using it as a backend for some real world. We have it shipped in production as backend for some mobile apps which have a considerable number of users. And the upside was that it was really easy to build. You don't need to know all the fancy specifics of other frameworks. And it worked really, really great. Thank you so much, and please let me know if you have any questions. I'm not sure if we have more time for questions now or anytime. I'll be here for the rest of the day, so feel free to come ask if you have any.
Can we split our Ktor application into microservices?
They don't have, like, by itself, Ktor does not have microservices support within itself. Basically, build one Ktor application for each of the microservices. The upside is that it runs really fast. As I was saying, it starts in 1 second. So for example, your auto-scaling to microservices goes really well. It can also be done in, so Google Cloud has something now called Google Cloud Run, where basically it's kind of serverless in the sense that you define your Docker image with your microservice, and then they scale up instances based on how fast, how many requests you have or not. This was really cool because it starts up in 1 second. For example, for that microservice, you couldn't use Spring because Spring takes at least 20 seconds to boot up. So that kind of messes your whole auto-scaling functionality. So yes, it does support microservices by the fact that it runs fast and it's encapsulated really nicely. Please.
Any other Java frameworks you've been using other than Spring? By chance, OSGI?
No, I haven't. Personally, I do not have any experience with that.
No other Java frameworks?
I've been using Spring, I've been using this one, and I've been using I've been playing a little bit with HTTP 4K. But again, it's like on the smaller side of things. But we are not, for example, in my particular use case, we are not a backend development company, so we don't have like huge, colossal APIs. The reason I wanted to show Ktor is because for someone like me, I'm working on like different startups or like projects or like things, I want to experiment really fast. So I don't want to, I want a tool that does what I want it to do for me and works really nice. Yeah.
Okay, thank you.
Welcome. Thank you so much, and yeah, see you later.